Hello and welcome to day 15. Today's is a pretty easy one, so we're just going to run right through it. For part one, we're going to implement our own hashing function on a string. So the way we're going to do this is start with the value of 0. For each character in the string, we're going to add the ASCII value, then multiply the entire total by 17, and then modulo by 256, feed that into the next character, and so on. What happens at the end of this is we're going to take a string and we're going to get a somewhat random number between 0 and 255, but if we put the same string in again, we'll get the same number back out every time. To implement this is pretty much what I just said. So for each character in the string, add its ASCII code, multiply by 17, modulo by 256. When we run out of input, we return whatever the value currently is. Great. So to complete part one, we just basically are going to split our input, map each item over the hash, and then sum that up. We're done. For part two, we're going to implement our own kind of rudimentary hash map. And the way that's going to work is we're going to have 256 boxes, which are labeled between 0 and 255. Conveniently, that is what our hashing function is spitting out. So the way this works is you can take any string, you can hash that string, and then you'll get a number between 0 and 255, and that tells you what box that data belongs in. And by doing it this way, we always know kind of where to go look. So if you have 256 boxes and you have 1,000 items more or less, then on average, each box only has 4 items in it. So you don't have to go search all 1,000 items. You only have to search a couple, and it's much quicker that way. The hard part, really, in the entire problem is going through and figuring out how they want all the data. So the way we're going to do this is the key is anything before a equals or dash. So like RN is the key, CM is the key, QP is the key, etc. And then to figure out which box we're in, we just hash that, we get our number and use that. If the line ends in a dash, then we actually want to go find that box and then just delete that item from the list. If it is an equal sign, then if that item already is in the box, we want to replace it in situ. We don't want to change the order of the list. If it does not exist, then we want to just add it to the end of the list. So what that means is like PC equals 4. It's the first PC in there, so we're going to insert it to the back of the list. And then PC delete, we'll delete it from the back of the list, or from wherever it's currently sitting. And then PC 6 will insert it back at the end of the list again. But if like this PC minus wasn't here and it was not the back, something else had gotten added to it, out of the list after that, then we'd want to replace the original one. We don't want to add it to the back again. So the way this works is we're going to create a list of lists, and so each boxes is a list of 256 elements, and each of those points to a new list, and then that's going to contain all of our data. We're just going to take our input, split it up, and then for each item in the input, if it's a dash, that means we want to delete it. So we're going to get the label, we're going to go get the hash of that label, we're going to find out which box it's supposed to be in, and we're going to remove it. If it's not a dash, then that means we want to add it. And so we're going to get the data to add, and of course the label. We're going to hash the label to figure out which box we're in, go get that box, and if that box already has an item with that label, then we're going to find out what that index is and just set the new index to the new item. So in this case, again, I'm using a pair of label and the data. And if that item does not exist in the original list, then it's much easier. We just add it to the back. Simple enough. Now to get our actual answer, we're going to go through here, and for each item, we want to multiply the box number plus 1. So 1 to 256 is the box number. Times the location number in that box. So again, plus 1, because everything is one index in the code. So if it's the first lens, it's 1. If it's the second lens, it's 2. And then we're going to multiply all that by the data, the focal length that they gave us, the actual number. And then return that, and that's it. So pretty easy one today. If you have any questions or comments, of course, hit me up in the comments below. Otherwise, the code will be up in the GitHub and everything. I'll see you tomorrow.